Hello friends, welcome to C# Intermediate to Advanced tutorial. Now we are at the final part of the subseries 7 Interlocked class. So in this video we will implement thread syncing or thread synchronization via Interlocked class. So in the first video, we learned about atomic operation and interlocked class. Then we talked about the example. Now we will implement the atomic operation, and if you see, when user clicks the atomic button, that means the interlocked button. So here is the click event. We get the maximum. We get the txt number and we store that as a sequence max. Then we are performing a thread sleep. Here we create instance of a countermon, which we used in our previous video when we learned about critical section using monitor enter and exit. So this is the object we locked using monitor enter and exit. The same we are going to achieve here in this video using the interlocked class. And here if you see, this is the parameterized thread start delegate as we did previously. This time we are naming the task as task 3. Then here we are creating 4 threads and we are naming the threads. After the yes, we are starting all 4 threads by passing the counter object. So this counter object is the one which is shared between all 4 threads, and the countermon object contains a single integer variable as a class member. That's what we are going to increment in all these 4 threads. In task C, if you see, this is the threaded task, right? So here we are receiving the counter and we are typecasting that. Then we retrieve the thread name. Here is the thread name. So from here we can say whether it is thread A or B or C or D. So that we will get here. Then using the sequence max, whatever you gave here in the text box, based on that we are forming the loop here. Inside the loop, if you see, counter 1, this is coming here as a parameter, and if you see, there are 4 threads that is going to execute this threaded procedure, and all 4 threads will make use of same counter object, because here what we are passing is same counter object for all 4 threads. So here we are incrementing the counter variable. seq counter is the member in the counter object, and we are incrementing it. So as already explained in the very first video, we know that this will turn into a 3 instruction set, and at present the below is not atomic because we are not using any thread synchronization. So context switch can happen anywhere in between, before executing step 2 or before executing step 3. Context switching may happen, and it can happen between all 4 threads. In the first video of this sub-series, we took only 2 threads for exploring it, but here if you see, the situation is even more worse. Why? Because we are using 4 threads, and context switching is more effective here. More effective means more effective to produce error result. All right. Next, if you see here, I purposefully commented it. Here we are making use of a sequence counter, right? Here we will see a problem, and to avoid that we can comment and uncomment this line, and interlocked dot increment, then counter 1 dot seq counter. So we are giving this object as well as the member to the interlocked increment. So this single step will execute the low level instruction as a single atomic operation. That means the context switch won't happen. All three instruction set will be executed. Then only we will come out of the increment operation, and the thread will go to the next statement. If T1 is entering and T1 is executing the first instruction set to achieve the increment, then it will make sure to complete all three instruction set. It will make sure means this interlocked class will make sure. So the name itself suggests interlocked. That means you no need to make a call to locking the resource. Here, since it is interlocked, the lock will be performed by the function call itself. Increment we are making call, right? Increment will perform lock here, and it will do unlock at low level instruction set level. All right, so here we print the sequence counter as we did previously, then we are providing some sleep. So when we go to the demo, first time we will increment it using the sequence counter, then we will try with the interlocked increment. Now let's go to the demo and implement the interlocked synchronization class-based increment. So here is the example. So now we will implement this atomic operation. So here we are starting task C. Everything else is same compared to previous one. That means here we are starting the thread, right, as part of the specific button click. So the same only we are going to try here. There is no difference except we specify task C. So as already explained, if you see, we use the sequence max. We create a delegate for parameterized thread start, and that delegate will point to task C. Task C is not yet created. Then we create 4 thread out of this task C by specifying the threaded task. Then we name our thread ABCD. Then we start all 4 thread by passing counter object as the parameter. So all 4 thread make use of same counter object. So now we need to write task C. The code is available for download. You can check the video description, and here is a task C, which was already explained in the PowerPoint slide. And task C is same like task B and task A, which we are doing the same stuff. We are trying to increment a variable content. So now here if you see, we are not using the interlocked class. Now we will run the sample. Okay, let's give a value of 20, and we will use so 20 means we need to see 80 here, but we are seeing 77 only. Let me give it as 50. So that means we need to see 200. So we clearly see a problem with this increment. Even though it looks like a unary operation, it is still giving issue. Now we will comment this and use interlocked increment. Now we will test this. Let me give value of 50. And here I am using the interlocked atomic operation. So here if you see, it ends exactly with 200 because the increment is performed as an atomic operation. So it's just like how we use the critical section, that means a monitor.enter and exit. Let me run this. And here also you will see 200 because of monitor enter and exit. So there are two techniques. One is monitor enter exit or the interlocked increment. So there are other methods also in this interlocked class, and if you see interlocked, you can perform increment as well as decrement. You can perform value exchange, that means assignment, add. So all these operations you can perform in a thread safe way. That means interlocked in the sense it will perform lock and unlock for you. And in our previous example, if you see, this is task B, right? We used it for the critical section based on, and it uses task B. Task B is here, and here if you see, we are making use of monitor.enter and exit. So enter will perform the lock, exit will perform unlock. Here we are performing the increment, and here we used the interlocked class and we used the increment. Then we passed, so this is passed by reference, forgot to say in the demo, and we passed our SEQ counter, which is here. That's the only member. We already saw this, just want to show again. That's all here in this video. Thank you for watching. Bye.